Just kidding. Let's work through this. For number 1, would you rather buy a car with a loan that charges interest or not have a car until you can save up to buy it with cash?
Save up.
Save up?
Yeah, I definitely would save up. How are you going to get the rent?
Just have a different car.
Yeah, that makes complete sense.
The interest rate
Yeah,
of the car.
Okay, let's gather these thoughts into one conversation with everyone. I'm hearing save up, but I'm also hearing, it depends, because you might need the car. But what's the point of the question? Huh?
She thought when I went nice, that was to her, but it was to you, because that was a good teaching move there.
I didn't know what she said.
Yeah.
Thanks. But let's think about the purpose of this question, right? What do you think the purpose of this question is for? What does it mean? Why does it matter? Yeah, Drake.
I mean, like, which one costs less?
Yeah, which one costs less? In the end, which one is you're gonna spend the less money, right? It depends. How does it depend?
Well, if you're smart with your money, if you get a car, that means you can travel to work more and work longer hours without being dependent on other means of travel.
What about gas, though? You gotta pay extra for gas.
I think she's just looking at purely price points.
If you get a
Buy
bike.
a car worth $30,000 and it's $30,000 cash, but if you buy a car $30,000 with a 5% interest, like every
Yeah. Okay, really liked what Jonas said. Okay, he got the point. If you buy a $30,000 car with $30,000 cash, it's just $30,000. If you take out a loan, it's going to be more than $30,000 with this interest.
Depends on how long it takes you to pay back.
Yeah. There's so many different things in it, but the point is the cost of the car is less if you save up and buy it, right? The actual price of the car. So yeah, there's reasons why a lot of people take out loans, because sometimes having the job makes you a little bit more money in the end. But if a job wasn't a factor and it's just you guys saving up money on your own and somehow you're getting money without a job. All right.
Thanks, Mom.
So this is a good question. This is the great job to pay for your car, right? A billionaire hires you to mow her lawn. For pay, she'll pay you 1 penny for the first job and then double your pay each time you complete a job. That's a really good job, right?
I mean, how big's the lawn?
It's a billionaire, so
It's a billionaire, so it's pretty big.
it's a big lawn. How much money would you expect to make on the third job?
4 pennies.
Okay, write a rule. That gives you how much money you will make on the nth job. So does somebody have one? They want to share. Yeah, Landon.
You could do 2 to the power of x over 10.
2 what?
The power of x over 10.
Oh,
2 to the power of x. X over 10. Okay, sorry. Do you mean the exponent is x over 10?
No, it's just like 2 to the power of x and that whole.
Okay.
Or you could do like the regular interest, which is like 0.01 in parentheses to no outside of the bracket or that.
Yeah? How'd you get that?
It doubles each time. So you put that over that would be to the power of 10 times 5.
Awesome. So that 0.01 is the penny, and it doubles each time, and so the 2 to the x is how many times is a double with each time. Perfect. We're going to make that x an n to match that variable, the nth job. Okay, so this next one, did anyone figure out how to solve that? If this is your equation, how did you solve that? Yeah.
You would plug $1 million somewhere there in for y.
Yes, so make it equal 1 million. Then on your calculators, you're going to go to y equals For y1, you're going to put the equation. And then y2, put 1 million. And then when you graph that, you would zoom out and find out where does it intersect. So where does that intersect on your graphs?
Most of them aren't gonna remember how to find that.
Yeah, where would you go?
You graph 1 million in Y1,
Uh-huh.
and you graph the other equation in Y2.
Yeah.
And then you go to second calc, and the 6th or 7th one down says intersection.
Okay, so on your calculators, after you've graphed the y1 and the y2 on there, you're going to do second calc.
But it may not work unless they change their window.
Okay, and then you go to intersect. It says first curve,
Yeah, that's what you just press enter.
second curve, enter, guess, yes. And just keep clicking enter until it gives you a number. And it says no sign change.
Do you want me to come up and do it?
Yeah, possibly. So I have the graph. 1 0 0 0 0 0 0.
All right, dudes. First thing you gotta do is,
You just have to move the iPad out of the screen.
oh, sorry. You guys got that in there? Yeah? Everybody good? So one person is good?
Oh, yeah.
Do you need another second to type it in or decide to answer my yes or no question? What's happening here? Are we good? You guys with me? You got your equation typed in?
Yeah.
Take a guess about how many years you think it would take.
34.
Okay, so let's go to our X maximum and change it to something a little bit bigger than that guess. How about 40? It's not going to calculate the intersection if it cannot see it in the window. You with me? And I should know what to make my Y max because I know it needs to be at least 1 million. So I'm going to make it 1.1 million. So it won't find an intersection point if you can't not see the intersection point. You with me? Everybody okay? Everybody that's trying okay? So you'll know if it'll find it because you should see the lines. Whoa, now I can see the intersection point, correct? So then second, trace, 5th one down says intersect. And you just press enter until you see the word intersection. And it is 26.58 years or however many.
Isn't it just times you mow it, not years?
Times. Yeah.
Oh, I wasn't
Your
even reading the
26th
question.
Time.
Oh, man.
26th time you'd make $1 million mowing a lawn?
I'm making a penny each time.
Wouldn't it be the?
Oh, wow. Yeah, it'd be the 27th time because the 26th time is just under $1 million. Yep.
Do you agree with the equation?
I don't know.
So you double each time, and you start with a penny.
No, times. So like if you mow it like once a month. And you,
So then your next time would be 2 pennies. Then, well, this is 1 million pennies. Well, that's what I don't agree with.
Ah,
Do you? So,
no, this is dollars because this is 0.01.
oh, because you changed it to 0.01, huh? Yeah, you're right. No, that's good.
So isn't that a good job? You just have to mow 27 times to make $1 million.
Your first paycheck's gonna suck.
First
Yeah.
paycheck would suck, but
Yeah, but I'll be able to get out of my
That's
bed.
half a year, right? It's basically half a year. You mow once a week for 6 months. Something like that. A little more. 7 months. Huh?
If you do it for 7 months, you're gonna be richer than the person paying you.
Well, they're a billionaire.
Yeah, so you're gonna be way over $1 billion in 7 months.
Well, yeah.
No, well, if you do it once a week for 7 months, yeah, okay.
After a while, the public have to pay you.
They're probably going to be like, you're done mowing my lawn.
Yeah.
Okay, so let's look at question number 3. If the initial population of puppies was 20, I love puppies. Sasha. If the initial population of puppies was 20 and grew to 25 after the first year, which of the following functions best models the population of puppies P with respect to the number of years T, if the population growth of puppies is considered to be exponential? Was this an exponential equation?
Was what exponential?
Was C an exponential equation, B and C?
Yes.
Yeah, because
There's an exponent.
the exponent was your variable. Yes. Okay. Which of these best represents? This should be really quick. Somebody raise your hand. Yeah, C. Maybe. What's 20 times 1.2?
Wait, isn't it? It's B.
I agree with B.
Yeah.
You started with 20, and on their first year, to get to 25 is times 1.25. And then every year after that, it multiplies on top of that. Okay? Do we get how we got B? Do we understand how we got B? Oh, do I need to recheck this seating chart?
Yes.
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 Not for you. You're doing so good. Okay, identify whether the following scenarios represent exponential growth, decay, or neither. Let's look at number 1. Is that decay or growth? What do you think? Yeah. Decay. Why do you say decay? Yeah, it loses. So we can understand that growth is going to grow. It's going to get bigger. Decay is going to get smaller or loses. So look for those words when you're reading these sentences, these statements. But what makes it exponential versus neither? Can someone explain, what do you think is going to make it an exponential or just a problem? Yeah, Early.
Did you ask what makes it neither?
Yeah.
Okay, just want to make sure. I think that A would be neither because it's just sharing the sales. It's not necessarily like giving everything.
Yeah. Yeah, I agree. I agree that B is neither because there's a share of 3%. Does anything, so the next day, yeah, go ahead.
No, keep going.
I want to hear what you have to say.
Oh, well, I was just, I was just thinking about on B, like, how you can tell that it's neither if you, for example, for like a bank account, you have multiple little like files or like, what are they called?
Accounts.
Accounts. And you still have the exact same amount of money, but you're just moving your money around. That's
Yeah.
kind of just how I saw it. I guess.
Yeah. Yeah, so for example, if you look at A, we figured out that this was a decay. It lost 20% every year. So does it matter at the end of each year? Does it matter what you made that year? To know how much you lost. Yeah. What about B? Does it matter how much you made the day before to know how much you make on that day? No. So you could think of the exponential growth or decay as it's building upon each other. It builds or it reduces. You need to know the day before. Yeah, Jonah.
It's like repeated multiplication on a base number.
Yeah, it's repeated multiplication on a base number. That's where the exponent comes in. Perfect. So we know that this is neither. So then we should all be able to say this one out loud. C. Decay. D. Growth. Pays. It's each quarter. Every quarter you have to know what you got the one before to multiply that 4% to it, right? The 3%, it didn't matter how much you made the day before. It just something different every day. All right, let's go on to figure this out. One of the primary ways we use exponential growth is in talking about financial accounts, right? It's the most common way with exponential growth is with our like interest rates on our bank accounts, all of it. Why am I not thinking of these words? Like credit card?
Credit card interest?
Yeah, like savings account or like credit cards. All of those interests, right?
The
Loans.
other really common
Those
way.
work as loans.
Yeah. The other really common way that you guys see this stuff, guys, listen up. Ladies over there, is with like medication. So like, you know, after you take like ibuprofen or Tylenol or something, it'll say don't take another dose after 8 hours, right? Or have you guys read that before, right? It's because you're waiting for the amount of medication in your blood. It's called its half-life to like go down. So like the exponential decay of medicine and things like that. I don't know. I was thinking of another example, but I don't know.
Yeah, no, like when I had to get off of one of my medications that I took regularly, I had to half it because of the half-life.
Yeah.
If it's too quick of a half-life, then you'll have withdrawals.
That and the bank account money being the growth. Those are the probably two most common ways you see exponential stuff.
Yes. Perfect. So you just earned $1,000 at your job. What are you going to do with that money? I feel like Ben.
Put it in a magical bank.
Oh, like Gringotts?
Yeah.
No, investing is up to
It's just
them.
magically protected. It's magically delicious. Yeah, she does. Huh?
I just said, we're talking about money, not lucky charms.
Oh. What are you going to do with your money?
Savings by a third. I would keep it in savings.
Yeah, put it in savings. I hope you all are talking about math. Good. Okay. Consider this magical bank that gives you 100% interest at the end of the year. If you put $1,000 into the account, how much will you have after 1 year?
100,000.
They offer you 100% back. You have $1,000.
Oh,
2,000. 100% of 1,000 is 1,000, so you add that on to the 1,000 you already have, so it'd be 2,000. Yeah.
A magical bank.
It would be a very awesome bank. However, instead of being paid $1,000 interest at the end of the year, let's say that they break it up into quarters. Okay? So this 100% interest we have has the rate of 1, right? Okay? Let's think about this broken into 4 quarters. How much, what is the percent of interest each quarter then? 25%. We're going to write that right there for right now. Okay, so will the amount of interest be the same each quarter, do you think?
No.
No, why?
Because you use it, you spend it, and then you also put money back.
Okay, so let's pretend like we're not spending any of this money,
well, so
but
you,
yes.
You get 25% of 1,000, and then you would add those, and then you get 25% of the first quarter plus.
Yeah, so no, because it changes. It depends on the previous quarter, right? Which changes. So first I want to think about something. Let's say we have 1 of a number and we add a quarter of that number to it. Can we combine those two variables? terms? Can we combine 1n plus 0.25n? 1.25n. So the reason I said that was that 1n is what you already had plus a quarter of it. So everything that you're going to multiply by is the 1.25. Does that make sense? Why it's not 1 plus the 0.25? We just combined it. So each quarter was 25%. Oh, that's where that 25 went. So if we had 1,000, we multiply it by itself plus the 0.25, so times 1.25. What do you get? 1,250. So from here to here, that was 1.25. Okay, what about the next quarter?
Just multiply by 1.25 more.
Multiply 1,250 times 1.25. What do you think is going to happen as we keep going? I just abbreviated so I didn't have to write that whole number. This is just 3/4, the third quarter, which was this. Oh my gosh. I wrote third quarter here because that represents the 1953.125. Okay, so I didn't have to rewrite it. And then what do you get? What's the last amount?
2,441.14.
So in cash, we just need to round to the second decimal place, right? This was bigger than this, right? How does that happen? It's exactly what we said in A, right? Huh?
It's because it's a one plate, etc. It's not just, it's more than one. Like
Yeah.
the rate is more than one, it's like bigger.
Yeah, the rate is more than one, and what happens in each quarter? Are we multiplying by 1,000 each time, or are we multiplying by the quarter before? Right, so your interest gains interest. That's why it goes up. So the interest gains interest. That extra 250 gained an 1.25 interest.
So compound interest.
Yes. This is called compound.
See, Jace, that's why I was trying to get you a loan.
You loaned Jason money?
No, he didn't accept it because I said I wanted 5%
these
interest
are-
every day.
You guys already have bank accounts, don't you?
I did when I was there.
I did. I was a spoiled last child, given everything. Just kidding, I really wasn't. I had a job.
I bought my own car. But you guys were like, oh, save up $30,000 to pay it cash. We grew up in different worlds, man. I bought my first car for $600 from a police auction.
Right? Any of
Yeah,
us are gonna
$30,000.
save up $30,000.
I still have not spent $30,000 on a
Or it
car.
was repoed, or it was left.
I mean, maybe I
somewhere.
have because of interest. Where'd Max
Take
go?
it away
You
from me.
can't buy a car for $699.
The odometer didn't work.
Okay, work on number 5.
Out of gas.
You
All
can
the
buy a
time.
bicycle.
Did you ever like take gas?
Just literally.
Oh, yeah, I mean, but I didn't have money for a gas can.
Okay, on number 5,
This was 2001.
how many months are in a year?
$5 cents a gallon. But I still couldn't afford it.
12 months in a year. So how many payouts? If you're going to just divide this 100% into monthly versus weekly versus daily, how many payouts are you going to have monthly? Like every year, if you're paid monthly, in a year, how many payouts are you going to have? 12. In a year, how many weekly payments will you have? 52. Okay. So you need to figure out what your interest will be for each of those. You're going to take that 100% or 1.0 and divide by the number of payouts. So this is your rate divided by the number of payouts, R divided by N. But really quick, everyone up here. Everyone up here. So side conversations, need to stop. On your daily, you're going to need 3 decimal places, okay? I need 3 decimal places for this to work. So go ahead and work on that with your tables.